As we look at these problems from Chapter 16, be sure you're asking yourself, what do I need to learn? What am I supposed to be understanding? What is it that I'm going to know when I really understand these problems? Well, we're looking here at the concept of entropy, the measure of how disordered a system is. And in problem number 23, the problem is asking you to choose between these pairs which of them has the greatest entropy, the most disorganization. Now remember, entropy is the amount of energy that goes into a material from the time it starts out at 0 degrees Celsius, from the time it starts out at 0 degrees Kelvin up to whatever temperature it is at. And so that's part of what entropy is. Of course, entropy also is how spread apart or how much energy a material has. So A, 1 mole of H2 at standard temperature and pressure, or 1 mole of H2 at 100 degrees Celsius, higher temperature, lower pressure. Well, the material with the higher temperature has more energy, and at the lower pressure means the particles are spread out, so the entropy is going to be much greater for this material. In B, we have 1 mole of nitrogen at STP and 1 mole of nitrogen at less than STP. So this is lower temperature, higher pressure. Well, lower temperature and higher pressure means the particles are going to be pushed closer together. They're not going to occupy as many positions. Lower temperature means the particles are not moving as fast. So here in B, this will have the greater positional entropy. In C, we're looking at 1 mole of water as a solid and 1 mole of water as a liquid at a higher temperature. Well, remember that as you change from solid to liquid to gas, we increase the entropy. Liquid to gas is a greater change in entropy than solid to liquid. So the material that's a liquid state will have a higher entropy. Also, it has a higher temperature, which means it has a little bit higher entropy. Moving on to problem number 24. Which of the following involve an increase in entropy of the system? Well, once again, we want to remember that if you have a solid compared to a liquid compared to a gas, that the entropy is much larger. Delta S here is smaller. Delta S here is much larger. So the process of melting is going to increase the entropy of the system. So let's go with melting. Sublimation is going from a solid to a gas, remember? And so that definitely is going to increase the entropy. Freezing, on the other hand, is going from a liquid to a solid. That is a decrease in entropy. Mixing is an increase in entropy, because if you the cases where we've looked at in the textbook of mixing may have been things like a gas in separate bulbs of this container and a valve removed so that we mix them, or mixing a couple things like alcohol and water and stirring them all around. Mixing is going to increase the entropy. Separation, on the other hand, separation is the opposite of mixing and is going to decrease entropy Boiling is changing from a liquid to a gas, and it's going to make a big increase in entropy of the system. So A, B, D, and F are going to increase the entropy of the system. Okay, moving on to number 25. Predict the sign of, I'm trying to work with too many things at once. Predict the sign of the change in entropy of the surrounding. So this is, we've got to remember that we're working with our system, and the stuff you see here is the system, and everything else is the surrounding. So if I draw everything here in the circle, now that's everything. This reaction that's written is this system. Now, if the system is going to take liquid and turn it into a gas, that's going to require an input of energy. Now, where does that energy come from? Well, that energy comes from the surrounding. And so this is going to cause a negative change in entropy of the surrounding. Now, if we don't tell you which we're looking at, of course, if we don't say, this is the change in entropy of the surrounding, just assume that we're talking about the system. But this problem specifies the surrounding. Now, in part B, yes, so we have A, the change in entropy of the surrounding is negative. In B, the change from a gas to a solid is what we're looking at here. Gas to solid. And that is a endothermic is actually an exothermic process. In other words, if we draw the universe, and this reaction is our system. Now, to go from a gas to a solid, we're going to have to take the gas and cool it and compress it and organize those particles. We're going to really have to decrease the entropy here in the system. So to decrease the entropy here in the system, we're going to be taking energy out of this and moving energy into the surrounding. So energy is going to flow into the surrounding, and so the change in entropy of the surrounding is going to be a positive number.